Hi guys, so finally I've started streaming. Now everything's okay. Just quickly let me. Oh, sorry. Okay, I cannot see myself live. Not yet. I cannot see myself live. Not yet. Why is it happening? I believe I should be. Yes, I am live. Now I'm live. Now I'm live. Hi Chetna, how are you? Hi Pragya, hi Chetna, how are you? कैसे हो? Alright. That's great, Pragya and Chetna. That's a great welcome. I hope that you guys will be present in all the sessions, right? The moment I come, so that I see a lot of students, right? So, it's a good feel. I feel better when, students are here. Okay. So, bache, we are going to ace in your term 2 examinations with Unacademy Plus, already. And I am not well. What happened to you, Pragya? Like cold and cough and fever, that sort of stuff. Because, cold ho rahi hai bahut. Like it's freezing here. Okay, tell me one thing. Chetna and Pragya, where are you from? Okay, take rest, beta. Take care, and again, like there is an outbreak of COVID outside, so stay at home and keep sanitizing your hands. Yeah, Chetna is from Jharkhand, okay, and Pragya is from Uttarakhand, okay, both are like great, Uttarakhand and Jharkhand, okay, that's nice. And that's great. And you guys have ISC boards, then share it with your friends as well, so that because a lot of students don't even know right now that this category has been launched. So it would be great, like if you help us to propagate it within your friends as well. So you guys know me already, but those who don't, I am your chemistry educator for ISC class 11 and for class 12. And I have done my graduation in University of Delhi in psychology, and it's been 5 or 6 years like I've been teaching cute and smart students like you, and now it's your turn. And as I always say, whatever doubt you have in any concept, any chapter, any question, just let me know, we'll get it sorted. Okay, and Pragya as well as Chetna, I have a complaint for you that you guys do not come to the special sessions. I have told you a lot of times. Pragya, Chetna, Yash, a lot of you. Why don't you guys join the special sessions? Those are free. At least come and experience like the difference between YouTube platform and the Unacademy platform. I wait for you, but you guys don't appear there. So I don't know. You guys are disappointing me, okay? Alright. Let's move ahead. Now you guys are not responding, huh? What happened? Okay. So what are we going to study today? We will be dealing with rest of the D and F block elements. D and F block elements. Sorry se kya hoga? When are you coming to the special sessions? It is D and F block elements, okay? Before starting with it, follow Unacademy Champions on Telegram. The link is given to you in the description box, okay? So when you simply tap on the link, you will land on the Telegram channel, so you can follow it. You will get you'll get the whole schedule of the day in the morning for YT classes, and for my Telegram group on which I post all my classes. So you guys can reach me by the username Kirti_Sharma 1223. This is my username, so you guys can always reach out to me. Okay, and of course subscribe us on YouTube, share it. A very small target we have for now, that is of 1000 subscribers. I hope we hit it very soon. You told me, but how does it matter? It hardly matters where are you, है ना? You can come to the class, online class hai, right? You know already that, guys, this amazing offer is going on, that if you get the subscription for a minimum of 12 months, that is for 1 year, then you will get extra 3 months free. So this way the subscription will be very economical for you. And apart from it, as you can see, that the batch has already been launched on 17th of January. That was day before yesterday, right? Or yesterday, no, it was day before yesterday, correct? And you can see, and also from February, I believe that physics teacher is also going to be here with us. And another thing is that if you subscribe for class 11, you will get class 12 subscription for free. And moreover, the whole deal is that, especially if you are siblings, okay, if you subscribe for class 9, you will get class 10, 11 and 12 subscription for free. If you subscribe for class 10, you will get class 11 and 12 subscription for free. And if you subscribe for class 11, you will get class 12 subscription for free. So if your siblings, like if one is in 9th or 10th and other one is in 11th and 12th, so you guys can avail this offer. And also you can use my code, that is Kirti S Live. My code is Kirti S Live. So you can use this code to get additional 10% off. So there are three deals which are working for you. Get the subscription for 12 months and get 3 months free. Subscribe for class 11 and you will get class 12 subscription for free. Use my code Kirti S Live and you will get additional 10% off. So these, right, Chetna? So this way you can take part, and it will be like very economical for you. Okay, so you can see here, and now we will start with D and F block elements. I have pretty good notes for you, which I have for you. You can see, yeah, here on the screen you can see that I have pretty good notes for you. Okay, yeah, here are like pretty good notes. So let's start with like D and F block elements. As we know, you can see here, let's start from the beginning. I just liked these notes. Okay, so you can see here, let's start from the beginning. Okay, let's read it like a chapter. Okay, because these are pretty good notes. So if we talk about D block elements of the periodic table, so we know that elements from the group 3 to 12, in which the orbitals are progressively filled in each of the 4 long periods. I have shown it to you in the previous sessions using the periodic table as well. Okay, the elements constituting F block are at the bottom of the periodic table, right? And those in which the 4F and 5F are progressively filled in the later 2 long periods. These elements are former members of group 3, which they have been taken out to form separate F block periodic table. I already told you I will take 6 March. Okay, what is the why 6 March? Like, what is your calculation, Chetna? What is the calculation? Why on 6th of March? I want to know like how students are thinking. What is their ideology? Let me know, Chetna. Okay, I'll just look when you tell me, okay? All right. So, where were we? Yeah, so we know like something like this is the shape of the periodic table, right? If something like this. So, we know that these are, let me change the color. These are the D block elements and the elements which are present at the bottom of the periodic table. Which are present at the bottom of the periodic table, these are F block element. Okay? The red ones are D block element. Ma'am, that day, अरे ये क्या कैलकुलेशन है बर्थडे पे सी okay, you guys are so cute. Beta, the simplest calculation is that, like, if you are in class 11, okay, so get the subscription now, because you will get class 12 subscription for free for the same time period. Okay, so these things are not based on somebody's birthday. This is based on your padhai, right? So make your decisions more practical, like when they are more useful for you, okay? Not on anybody's birthday. If it is Radha's birthday, then cut cake, go outside, have fun, hai na? So that's like more, it feels more like birthday, okay? You guys are so cute. All right. So yeah, we talked about D and F block elements. So here you can see that the transition elements are those which have incompletely filled d subshells, or you can say incompletely filled d orbitals, correct? In their ground state or in any one of their oxidation state as well. Copper, silver, gold are transition metals because in their commonly occurring stages, they have partially filled D shells. But we have already discussed in the previous sessions that zinc, cadmium and mercury, these do not account in for transition elements. Why? Because in case of zinc, cadmium, mercury, please repeat after me that this is zinc, cadmium and mercury. They are not transition elements. Of course, they are D block elements, but they are not transition elements because in case of these three metals, that is zinc, cadmium and mercury, the D subshell is fully filled. That is why they are not transition elements, okay? So you can see here that zinc, cadmium and mercury of group 12 do not have partly filled D subshell in their elementary state or in commonly occurring oxidation state, and hence they are not considered as transition elements. However, being the end members, their chemistry is studied with transition elements, okay? Although they are not transition elements, but phir bhi, like we keep it in that group so that like we can just study about their chemical properties, okay? General electronic configuration we have already shared. It is N-1D 1 to 10, NS 1 to 2. Take a moment and remember this configuration. Take a moment, write it 2 times on your with the help of pen and notebook. Write it at least 2 times, okay? Yeah, zinc, cadmium and mercury. Good, Chetna. Also write the electronic configuration or the general electronic configuration of the transition elements, okay? We have discussed the 3D, 4D, 5D series. We'll do it again, don't worry. So you can see here the transition series. The D block elements are called transition elements as they represent change in properties from most electropositive, that is S block elements, to least electropositive, or you can say they are electronegative P block elements. Transition, see, moreover, why are they called as transition element? क्योंकि we know that the S block elements कैसे होता है? We know that here S block elements, here D block elements, and then here P block elements, और नीचे bottom पे F block elements. So S block, P block, बीच में है D block. So the S block elements are your electropositive in nature, right? They are ready to donate electrons. And as we move towards the P block, they become electronegative, right? So here you can see कि transition हो रहा है. Electropositive से electronegative की तरफ there is a transition. That's why they are called as transition elements, okay? That's the reason why they are called as transition elements, okay? So yeah, transition series, as you know that the D block elements are called transition elements as they represent change in properties from most electropositive S block elements to least electropositive, and here it should be or most electronegative, not positive, it should be negative. P block elements. ठीक है, चेतना, प्रज्ञा, let me know. No doubt till now. So you can see here that transition elements have 4 rows. How many rows are here? You have 4 rows. 3D series, 4D series, yeah, 3D series, 4D series, 5D series, and 6D series. So there are 4 D series, okay? You need to remember the first transition series, that is from, okay, good Chetna, that is from scandium to zinc. It is your first transition series, that is your 3D series, and you need to remember the whole series, okay? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Take a moment and quickly remember it, okay? Just quickly now, scandium, titanium, vanadium, let's do it. 3 के ग्रुप्स में करते हैं. Scandium, titanium, vanadium, chromium, manganese. Let's do it this way. Scandium, titanium, vanadium, 3 हो गए. Chromium, manganese, chromium, manganese, iron. Let's do it this way. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. ठीक है, 4 जो लास्ट में 4 है, these are easy ना, cobalt, nickel, copper, zinc. शुरू वाले scandium, titanium, vanadium, तीनों M पे एंड हो रहे हैं, राइट? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Chetna, quick, repeat after me. Fast, fast, fast. Do it when you are studying it. Scandium, titanium, vanadium, chromium. इन चारों को ना साथ में कर लो. सभी like all are ending with an M. So scandium, titanium, vanadium, chromium. बीच के दो manganese, iron, cobalt, nickel, copper, zinc. Is it done? Did you memorize it? Tell me guys, did you memorize it? Chetna, Pragya, let me know बच्चे. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. मुझे याद हो गया. See, I memorized it. I memorized it with you. ठीक है? Cool? So, like I've already told you, alright, when you want to jump from 3D series to 4D series, when you want to jump, that's great Chetna. When you want to jump from 3D series to 4D series, I've told you in the previous session, you add 18 to it. Can you see? 21 plus 18, 39. अगर if you want to, like for your clarity, if you want कि आप just scandium से नीचे, just below scandium in the 4D series, what will be the atomic number? So simply add 18. So you can say yttrium का atomic number is 39, है ना? Or you can see if you want to calculate what is just below zinc, 30 plus 18, 48. So it is your cadmium. If you want to jump from 4D series to 5D series, then you add 32. Then you add how much? 39 नहीं बेटा, it's 32. ठीक है? 18 and 32. You can see 39 plus 32, it's 57. 41 plus 32, it's 73. Okay? So that's how you can jump from 3D to 4D, 4D to 5D. We won't be talking about like 6D series a lot because 6D series is radioactive in nature. It is radioactive in nature, and moreover it is not in our syllabus. Okay, one more thing is that always remember the configuration. See, the configuration, like if we talk about 3D series, always remember the configuration of chromium and copper, because see, chromium has half filled configuration. We have done this in the previous sessions. Chromium has half filled configuration and copper has fully filled. Here you can see that 3D10, 3D5, 4s2, 4s1. ठीक है? (3D5, 4s1 and 3D10, 4s1. ठीक है guys? Is it okay, Chetna? And moreover, see, we know already the atomic number of chromium is 24. For copper, it's 29. So if you want to see like just the member which is below chromium, so below it's molybdenum, you can see MO, right? So in case of molybdenum as well, for the same reason, it will also have half filled configuration, 4D5, 5s1, right? 4d5, it should be 5s1. 4d5, 5s1. And copper ke just niche is silver. So for silver, that is why copper, silver and gold just below silver. These are very, you can say, stable elements. है ना? We use it in our jewelries and ornaments as well. Correct? You can see copper, silver, gold. Right? So they have, as you can see here, fully filled and here half filled configuration. ठीक है? And we won't be dealing with 6D series because it is radioactive in nature. It is radioactive in nature. Let's move ahead. We discussed some of the properties of the, now you can see now, I guess. Better? No. Okay, we can just, let's zoom it, and so that you guys can see clearly at least. Okay? Yeah, now it would be better. Let me see. Yeah, I'll just scroll it down so it will be, pretty, like it would be more visible for you. All right. So we discussed about atomic radii. We know that when we move from left to right, what happens? The nuclear charge increases, right? When you move from left to right, what happens? The nuclear charge increases. Let's see, let's read all the general properties. We have done them already. It's just that we are discussing them. So here you can see, when it comes to atomic radii, if you compare between S block and P block elements, so it is in the intermediate, beech mein hai, okay? When you compare it with S and P block elements. So the atomic radii is intermediate between those of S and P block elements. So what are the trends in this? So you can see here that atomic radii of the elements of a particular series decrease with increase in atomic number, but this decrease in atomic radii becomes small after midway. Okay, let's discuss the reason behind it. Okay, what do we know? When like your quite obvious, when you move from left to right, there are two types of forces which work, right? One is electron repulsion, and the other one is the attractive force between the nucleus and the electron. Let me show you here. If this is your nucleus, this is the inner shell, this is the outer shell. Okay, so we know that here you will have like electrons in this way. So the two types of force which are working are, these electrons will repel each other, and this nucleus will try to, मैम से all students to answer. अभी तो मैं समझा रही हूँ ना. I'll ask everyone, don't worry. Okay, so yeah, the atomic radii decrease in the beginning because of increase in atomic number. The nuclear charge goes on increasing progressively, right? When you move from left to right, atomic number increases and your nuclear charge also increases, right? But the electrons enter penultimate shell, and the added d electrons screen the outermost s electrons, right? We know already that this is screening effect. When the electrons of the innermost shell repel the electrons of the outermost shell, it is called as your screening effect. Okay, so when we move, you can say from scandium to manganese, from left to right, when we move from scandium to manganese, then the size decreases. Okay, from manganese to further like to iron, the size almost remains the same because these two forces kind of compensate each other, and after this the size increases. Okay, so yeah, but the electrons enter the penultimate shell, and the added d electrons screen the outermost s electrons. That is, screening effect comes into the picture. The shielding effect or screening effect, we have discussed, it is the same. So the shielding effect is small, so that the net electrostatic attraction between nuclear charge and outermost electrons increases. Consequently, atomic radius decreases. Okay, so as the number of d electrons increase, the screening effect increases. This neutralizes the effect of increased nuclear charge due to increase in atomic number, and almost it remains the same in the after chromium, right? ठीक है, is it clear? We have already done this Chetna in the previous sessions as well. And I told you that in the end, the atomic number, the atomic number, atomic number increases, but the size also increases. Why? Because at the end, there are more electron repulsion. See, जैसे जैसे आप आगे जाओगे, the moment you will move forward, there will be more number of electrons in the d orbital. So when more number of electrons are present, so there will be, like you can say, more repulsion between the electrons. If repulsion is more between the electrons, so you will say na that the size will increase. Agar, like I'll show you again, if there is more repulsion in these electrons, so these will like try to move apart, दूर जाएंगे एक दूसरे से, and hence you will say that the size will increase. ठीक है? Is it okay, Chetna and everybody else out there? So you can see here, therefore electron cloud expands and size increases. Okay. Next, atomic radii increases while going down the group. Now whenever you go down the group, जब भी आप ग्रुप में नीचे की तरफ चल रहे होते हो, then what happens? New shells are being added, right? So when you jump from 3D series to 4D series, तो साइज क्या होता है? इंक्रीज होता है. Seems logical as well, ma'am. You jumped from 3D series to 4D series, so like new shells are being added, so quite obvious that the size will increase. But what is the issue here? When you move from 4D series to 5D series, now reason is still the same. Okay, ma'am, when you will jump from 4D series to 5D series, again there will be like new shells will be added and the size will increase. But actually में 3D से 4D आए तो size increases. When we jump from 4D to 5D, the size almost remains the same. Array, why this happened? It is because when you jump from 4D to 5D series, in between you have to fill 4f orbital first. है ना? You have done this in class 11 chapter number 2. Okay, if you have any doubt, then please revise like your all the rules, Hund's rule, Aufbau's rule, है ना? How to fill electronic configuration. So before this 5D, you have to fill 4f orbital, and you know that screening effect, the order of screening effect, S का सबसे ज़्यादा होता है, then P, then D, and in the end it's F. So the screening effect of F orbital is very poor. That is that it won't repel the electrons. So as a result, your size will almost remain the same. Okay. Let me drink some water. In study of compounds, क्या what are you saying, Chetna? What do you do in the study of compounds? So you can see here, this is associated with the interventions of 4f orbitals which are filled before 5d orbitals. That's what we discussed. 4f orbitals have poor screening effect. 4f orbitals have poor screening effect. This results in regular decrease in atomic radii, which compensates the expected increase in the atomic size. ठीक है? Is it clear, guys? When it comes to ionic radii, it follows the same trend as the atomic radii. ठीक है? From left to right, first decreases, then constant, then increases, and from like down the group, 3D to 4D size increases, 4D to 5D size almost remains the same. So your ionic radii follows the same concept. ठीक है? Next is metallic character. So you can see here that all transition elements are metals. All of them are metals. Okay. They are very hard. They have high melting points, high melting points, high boiling points. They have high tensile strengths. They have ductility, and there is thermal and electrical conductivity, and they are lustrous. That is, they shine. You have done this in class 7 or 8, I believe. Okay. Now, what is the reason of metallic character? The reason is again that they have they have large number of unpaired electrons, and those electrons take part in bonding, which results in metallic character, and all of these properties we just discussed, that is high melting point, high boiling point, high tensile strength, ductility, and more thermal and electrical conductivity. Okay, cool. Let's move ahead, that is density. So all metals have density. Within a period, the density is vary inversely with the atomic radii. So that is, density increases along a period, and it also increases upon descending down the group. Okay beta, all the best Chetna. All the best Chetna. Okay, and to all the students, and to all the students, ठीक है, चलो, cool. All right, let's move ahead. So you can see here melting and boiling points. We have already discussed that transition metals have high melting point and high boiling point, right? So you can see here that the melting point and boiling point of metals rise to a maximum value, like something like this is the graph. When it comes to melting point or boiling point, they first increases and then they decrease. Okay, so the melting point and boiling point of metals rise to a maximum value and then decrease with increase in atomic number. जैसे जैसे आप आगे जाओगे, they decrease, the melting point and boiling point decrease. Okay, however, now here is the exception. Okay, manganese and technetium, Mn and Tc, have abnormally low melting point and boiling point. Okay, so this is the reason, these are the exceptions here, manganese and technetium. Okay, so the high melting point and boiling point is due to strong metallic bonds as usual, because they have large number of unpaired electrons which take part in metallic bonding, and as a result they form strong bonds, and consequently they have high melting and boiling points, right? So you can see here that the high melting point and boiling point is due to strong metallic bonds between the atoms of these elements, right? The metallic bond is formed due to interaction of electrons in the outermost orbital. The strength of bonding depends on number of the outermost electrons, the number of electrons which are present in the outermost shell. So you can say that greater the number of valence electrons, that is the more number of electrons which are present in the outermost shell, stronger will be the metallic bonding, and consequently melting point will be high. ठीक है? Now the reason why Mn and Tc show like a dip in the curve, something like this is curve for Mn, it is like this, and then it decreases. So it is like it shows some abnormal nature. That is because like manganese की जो already electronic configuration होती है, it is quite stable, right? It is already quite stable. So as a result, 3d electrons are more tightly held by manganese atomic nucleus, and this reduces delocalization of the electrons, resulting in weaker metallic bonding comparatively. ठीक है? I hope that there is no doubt till now. Okay. Just give me a moment, guys. Okay, let's move ahead now. Now we will discuss. Now we will discuss ionization enthalpies. Okay, so what is the trend in case of ionization enthalpies? That is, you can see that the ionization enthalpies of the D block elements is quite higher than those of P block elements. So you will say that the ionization energy increases along a series, right? Now what is the reason? What is the reason for that? So we know that the increase in ionization enthalpy is due to effect in due to like increasing nuclear charge, right? So what would happen because of it? So which would tend to attract the outer electron with a greater force, like the moment like your nuclear charge increases. Nuclear charge is increasing, so it will attract the electrons with a greater force, right? So consequently kya hoga? Ionization enthalpy is it is expected to increase, है ना? Because now it becomes even more difficult to pull that electron out, right? So your ionization enthalpy will increase, but the addition of electrons take place in last but 1d subshell, and this increases screening effect, that is the electron repulsion decreases, right? Okay, sorry, it increases, the your screening effect will increase, right? So with the increase in electrons in the d subshell, so they are shielded more, that is they will be the electrons will be like will be pulled together, like they will repel each other with a stronger force, right? The outermost shell and the innermost shell electrons, correct? So with the increase in electrons in d subshell, the outer electrons are shielded more and more. Thus, effect of increased nuclear charge is opposed by additional screening effect of the nucleus, and ionization enthalpy increases. But it increases slowly. Okay, धीरे धीरे वो बढ़ती है, ठीक है? The irregular trend in first ionization enthalpy of the first transition series of elements is due to the effect of that removal of one electron alters the relative energies of 4s and 3d orbitals. Okay, so what are some of the exceptions? You can see here, I already told you that chromium and copper, because of their half filled and fully filled configuration, they will have high ionization enthalpy. Why? Because chromium and copper, they are already stable, right? They are already very stable, so they will it will be difficult to pull out an electron from them, okay, because they have completely filled or half filled d configuration, okay? So that is why it becomes difficult to pull out an electron, okay? So you can see here, chromium and copper have high ionization energy. This is attributed to their half filled, that is D5, and completely filled, that is D10 electronic configuration. Okay. Okay, I'm a bit, let me talk a bit slowly. Okay, my throat is gadbad in winters. Hi Sohrab Raja, why are you so late today? The value of second ionization enthalpy for zinc is low because ionization involves removal of an electrons resulting in the stable 3d10 configuration. So the first ionization enthalpy's value is okay, but when it comes to remove the second electron, the now zinc is already in a stable configuration. Now zinc does not want to lose that configuration, so that is why it will have like the second ionization energy is a bit low. Okay. With oxidation states, I have told you already, when we go to the middle of the series, just like in this case, you can see that manganese show a variable oxidation states, right? That is, you can see that manganese here can show oxidation states from +2 to +7. So it is generally seen that when we move in the middle of the series, it shows the element shows the variable oxidation states. Okay, here you can see that manganese can show from +2 to +7. Okay, so you can see here transition metals exhibit a large number of oxidation states in their compound. Okay, except SC, the most common oxidation state of the first row's correlation elements is +2, which arises due to loss of, obviously because of 4s electrons. Okay, so here are like some points regarding the oxidation states. You can just simply read them. Okay, and let me know if there is any doubt. Okay, and let me tell you some of the important. So you guys already know that the batches have already been launched for class 11 and for class 12, right? The batch which is going on right now is Mavericks, and there are basically, you can say, 3 deals simultaneously. That is, all together you can take advantage of 3 deals. The first one is that if you subscribe for class 9, you will get class 10, 11 and 12 subscription for free. If you subscribe for class 10, you will get class 11 and 12 subscription for free. And if you subscribe for class 11, you can see here, if you subscribe for class 11, you will get class 12 subscription for free. Okay, so this is like a very good deal. And apart from it, this is a deal which is like going on, that is, if you get the subscription for 12 months, you will get extra 3 months subscription. So this is second deal, that if you get the subscription for 12 months, you will get 3 months extra. You will get 3 months extra. Okay, and what is the third thing? You already know my code, that is Kirti S Live. My code is Kirti, KIRTI, Kirti S Live. Okay, so you can use this code whenever you want to get plus subscription or you want to enter in the free live class. Using this code, you will get flat 10% off. You will get flat 10% discount आपको मिल जाएगा. So if you use these 3 deals together, that is like get the subscription for class 11 and you will have class 12 subscription for free. Get the subscription for 12 months and you will get extra 3 months free. and use my code, that is Kirti S Live, to get flat 10% off. All right. And you already know that these are the features of Unacademy subscription. That is, like, you already know that there is an outbreak of COVID now, so it's better to just stay at home and study with the top educators of India, right? You will have a fixed schedule. Okay, evening batches are going on these days, so you can take part in them. You can enroll in them. You know already the Mavericks batch is going on, right? You will have unlimited access to all the courses which are available in that category, है ना? There are regular doubt solving sessions, doubt clearing sessions. It is mandatory in plus courses that every fourth session is a doubt clearing session. Okay, so like there is an exhaustive coverage of the syllabus, and we are here for you, for the mentorship, for the guidance. We provide you the whole study material. There are practice tests, live tests, batch courses, and whatnot. Okay, so as I've already told you that these deals are already written here, and you can use my code Kirti S Live. Don't forget to use it, so that you will get additional 10% discount. Okay, and these are the existing batches: Param batch, Champions batch. You can see these are the existing batches. Okay, you can see here. So I believe that you all will be there in the plus sessions, so that we can cover 100% of the syllabus. Okay, so you guys can simply download the Unacademy app, go for ISC class 11 or for class 12, and you will find me there, Kirti Sharma. Okay, and so you can watch all the special sessions, plus sessions, you can watch everything. Okay, so that is it for the day, guys. Download the Unacademy app right now, and let's crack it. Here I have given my username for Unacademy Messenger, for Telegram, and for all the social medias, so you can use it. And my code is Kirti S Live. Okay, so that you will get an additional 10% off. So that is it for the day, Saurabh, Chetna, Pragya, and everyone. Okay, let me know if you have a doubt. That is it for the day. See you in the next session. Okay, so take care, guys. Bye bye. Good night.